So today, actually, the last topic is remaining. Then our first unit will be completed. So actually, first I want to recapitulate what we have discussed in unit number 1. So if you have missed any lecture, you can easily understand the remaining topic as well. You will come to know the unit number 1, and today evening or up to tomorrow I will share assignment through Moodle. As well, I have uploaded PPT, all video lectures on Moodle. Even the styling book also I have uploaded. So you can refer PPT, all video lectures from the Moodle. And all you have to attempt all the assignment, the test, I will schedule on Moodle. Okay. So yes, yes. Just a minute. Sir, लास्ट लेक्चर में ऐसा हो रहा था कि ऑटोमेटिकली ये हो जाता है ये अभी देखते हो आप इस okay. So the second topic that we have discussed, that is architecture and organization. So in architecture and organization, I hope you could remember this, what we have discussed in this topic. Architecture is actually the low level concept. Uh, Here we have seen actually this architecture concept is mainly their attributes are visible to the programmer. So it is low level concept means a basic logic unit that knows to the every programmer, and the programmer directly can use all these attributes. The for example, like if you want to multiply, uh, so this is lower level concept, and if you want to multiply, so the programmer knows how actually he can multiply. He knows what are the instructions are available, and by using that instruction he can multiply. So architecture is a actually abstract model. Why it is an abstract model? Because the programmer knows only the multiply instruction, but he is not bothering about how actually that instruction is executing. He simply use that multiplying instruction and he perform the operation. So that's why it is actually, we can say it is a though there is a contradiction, like we are talking about is a lower level concept, but actually the it knows to the programmer, and broadly he know only the if he want to multiply, so which instruction is available, and he simply use that instruction. So the programmer always deals with what are the functionality is being provided. So all comes under the architecture, like the instruction set, number of bits used for data representation, what are the input output mechanism is there, addressing technique is there. So basically, whenever we are talking about the architecture means what does system do? That comes in the architecture. What does the system do? So, so what? So you have to remember architecture means what, and organization means how. So in organization refers to the operational unit and the interconnection between them to achieve the architectural specification. For example, in architecture, we have seen if you want to multiply, yes, multiplying instruction is there. But in operational or in organization, you will come to know how actually we can this multiply instruction implemented. Uh, for example, directly by using hardware, we are multiplying or we are adding the same number multiple time, and in this way we are getting a multiplication. So actually how it is implemented, it 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 concern in organization. This is the concern of organization. So your architecture is lower level concept, but the organization is higher level concept, like instruction, number of addresses we are using. For example, if you are using any instruction, what the number of addresses we are using for to execute that instruction, and which is transparent to the programmer. Like the programmer does not require to know how actually is getting a functionality. Like you have used the multiplication and division in the C program, right? But very simply, you have used all these instructions, but you have not taken any consent about how actually these instructions are implemented in header file, and how actually these two variables values are multiplying together. No, actually it is not required for the programmer. So all these things comes under the organization. In organization means how to implement a functionality. So in organization, we'll see the control signal, interfaces, memory technology. So in a simple, the same thing I had explained you with the one analogy. Like for example, if you want to buy a house, so in architecture you will see how many rooms are there, the terrace is available or not, and on terrace the pipe water supply is available or not, how many bathrooms are there, in every bathroom the water supply facility is available or not, balcony is there. So all comes under the architecture. What are the facilities are available? And organization means how actually you are getting these facilities. Suppose on terrace you are getting water. So how actually pipeline connection is there, right? How actually all the pipelines are connected with each other. So architecture means what and organization means how. But in this way, you can easily understand your subject title, that is computer architecture and organization. Architecture and organization. So in this subject, we are going to discuss about both the part, that is what part and how part. What are the things are available and how you are getting all these things. It could be the functionality, it could be the actually how actually you are getting that functionality. The next topic, in this topic we have discussed the structure and the function. So structure means actually how the different components are there and how these components are relate to each other. So it comes under the structure. Like in a computer, how many components are there? So the processor is there, memory is there, input output devices are there, and how these devices are related to each other, it comes under the structure. And function means the operation of individual component. So operation of individual component means if I am asking you what is the operation of input output devices, you can easily tell the input output device purpose is what are their function to take an input, as well as after processing your processor send the output to the output device to display the result. So that is a function. Function means the operation of individual components. So whatever component in the structure, their operation will see in a function. So we can use a top-down approach. As we have seen, the top-down approach is the clearest and most effective approach. So function means the operation of individual components. So in a computer, there is a processor is there, memory is there, data connection is there, control unit is there. So each unit having a different function. Like data processor, the processor main function is to process the data, and store memory to store the data. Again, there is a two types of memory: short-term and long-term memory, primary and the secondary storage. Data movement means there is a interconnection in between input output devices to processor, processor to memory. So data movement is there in between these devices, and control unit is there to control all these functions. So in function, there is these are the different components and their operation. In functional view, we have seen actually these are the different components are there and how actually they are providing, how they are operating. For example, the control unit is there, data storage is there, data processing is there, and data movement is there. So each unit having its own different function. So we have seen here all different unit having different functions. So for example, data movement. In data movement operation, simply actually we are transferring data from one peripheral to the another peripheral. That is a communications in between two different units. In data storage, actually your data movement is there from outside, from the input device to the data storage. Processing, so actually you are from the memory storage, the control unit is there. So data movement is there from the storage to the processor, and after processing again, we are storing the data into the storage. So all comes under the operation. And in the structure means actually how the components are related to each other. So in function, we have seen actually these are the different unit and it's having its own function. Like data movement is there, data processing is there, data storage is there. So each unit providing a different types of function, and structure means how actually these components are relate to each other. So therefore, to understand this, we use a top-down approach. The top-down approach is the best way to understand a complex thing, like the hierarchy from the top to bottom. We are analyzing one component in detail. Like suppose if we are talking about the computer, so in a computer, if when you will open a computer, you will come to know, yes, there is a CPU is there, main memory is there, okay, input output connection is there, and all these different units are interconnected together. So you will call it as a computer. So again, if you will use a top-down approach, then you will open a CPU, central processing unit. So in central processing unit, you will find is registers are there, ALU is there, control unit is there, and again you will find all these units are interconnected with each other. So structure means how actually these different units are connected with each other. These things we have discussed in this topic. The next topic is program concept. In program concept here we have discussed, like suppose here I have given an example of calculator. In calculator is your hardwire system. And if you will compare the calculator and your computer system, you will find your computer system is more flexible and your calculator is inflexible. Like if you want to add a new functionality, if suppose if you have developed one application in a computer, and if you want to add a new functionality, yes, you can easily add the functionality because your computer program is very flexible, because you are you are getting all this functionality by simply the code. But in the calculator, actually, it is hardwired. Hardwired, that's why it is inflexible. If I told you, if I tell you to add a new functionality in the calculator, it would be very difficult for you to add a functionality in the calculator, right? So in general purpose hardware can do different tasks by giving correct control signal. Like in the calculator, if you are if you want to add 2 plus 2, the functionality already implemented, you will get easily the answer of 2 plus 2, because for the plus is a unique control signal that is provided. But and suppose if you want to add a new functionality, you have to provide a new set of control signal. So suppose if you want to add a new functionality, what you have to do, you have to provide a new set of control signal, and you have implemented with the hardware, and all it is not easy to add a new set of control signal. So for each operation, a unique code is provided, like add, move. So these are these different types of instruction that we have to add. So here, actually, you will find there is the same thing here. The programming in the hardware that is inflexible. We cannot add a new set of unique control signal here. But here, this is a programming in software. In software, we can provide instruction code. Instruction interpreter is there, and by using this, we can add a new functionality in our program. So this is nothing but with the computer. In computer also, we can add a new functionality by providing instruction code. So for each instruction, there is a unique control signal is there. So actually by this unique control signal, we are adding a new functionality. So actually in a computer, how actually we can add a functionality by the program. So what is a program? Program is a sequence of steps. And for each step, you will find there is an arithmetic and logical operation. So for each operation, a different set of control signal is needed. So in C, you have implemented a program. So in every program, you will find there is a sequence of steps and the components. So actually now, so You have written a program, but now you want to execute the program. So to execute the program, different types of components are required. So what are the different types of components required? So the control unit and the arithmetic logic unit is required, because control unit generate a unique control signal, arithmetic and logic unit ALU required for the arithmetic and logical operation. So this control unit and arithmetic logic unit constitute the central processing unit, CPU. Second one is input output unit, and third one is main memory. So these different components are required for the instruction execution. So here actually we have seen how actually the instruction executed. So it is a one Neumann machine. In one Neumann machine, actually at the very beginning, how you were the computer is very simple, and how actually it execute the instruction. So this diagram we have seen, PC is a program, counter is MAR is a memory address register, MBR memory buffer register, IR instruction register, execution unit is there, input output address register, input output buffer register, input output module main memory. So what we have discussed in this diagram, PC hold a address, the address of instruction that you want to execute. For example, here is the 3. So the 3, PC hold a 3 instruction address. That 3 passes to the MAR. So MAR read the address, and to read the instruction, his read control signal generated, and the respective instruction, for example, 3 address is there, so third address instruction read from the main memory and loaded into the MBR to the IR. Now IR hold the instruction that you want to execute, and for that instruction, to execute that instruction, if the data required, again particular data loaded into the MBR, then instruction executed in the execution unit. And for the execution unit, whatever data required is transferred by the MBR. So after the execution finish, respective output will be stored into the MBR. And for the according to the MAR address, the whatever your result is there, it will be stored into the respective memory address. So this thing we have discussed for this computer components. Now to actually execute any instruction, there is 2 cycles required, that is fetch cycle and execute cycle. Fetch cycle means to fetch an instruction, and execute means to execute the instruction. So actually how the fetching is done, this thing you can understand here, how actually fetching is done. So actually memory holding these different types of instruction as well as data, and at respective address memory location, and PC is holding the instruction that is for the address of 300. AC is accumulator, IR is an instruction register. So PC hold a 300 address. So this 300 address loaded into the IR instruction register, that is 1940. What is a 1? 1 is nothing but the unique control signal. So this 1, what is the meaning of 1? Transfer data into accumulator. So which data actually? The data at the location of 940. So at 940, the data is 0003. So this data will be loaded into accumulator. So here you could see the data loaded into the accumulator. Then here the PC is incremented by 1. So instead of 300, here it became 301. So at 301, again, this 5941 loaded into the IR. So what is the meaning of 5? 5 means add. But this accumulator value will add with the location 941. So at 941 is 0002. In this way, the addition is done and respective value is loaded into the accumulator. After that, accumulator result again stored back into the main memory. So in this way, we have seen the fetch cycle and execute cycle. How actually first we have to fetch an instruction, and then respective data we have to fetch, and after the execution we have to store our result at the respective location. So all these things we have seen in the example. So in the operating steps we have seen how actually the instruction execute. There's another by this state diagram we have explained the same thing. So the unit number 1 is very easy. If you observe, our overall discussion is somehow related to this diagram. So if you could understand this diagram, you can answer any question. Like instruction address calculation is there. So at the PC, hold this address, then instruction page loaded into the MAR, then in the instruction page, respective location, we have to page the instruction. After paging the instruction operation decoding is required. So after decoding, we have to page the respective data which is required for that instruction. For example, the two variables are required, 2 times we have to page the data. So respect operand address calculation. So operand means require the variable. So for that, the address calculated, and for the respective address, a data loaded, page. So after paging, the data operation required. So whatever the instruction is there, as per the instruction, respective data operation will be performed. Then you will get the result, right? So we have to store the result. The multiple results are there, so multiple time we have to store a respective operand. In operand, the result is there. Then sometime we have to pass the result for the next mathematical operation or any kind of in the execution. So the respective result will be transferred to the operand address calculation steps. Otherwise, the next instruction, the computer is ready to fetch the next instruction. So this is a very simple instruction cycle state diagram. Another concept I hope you could remember, that is interrupt. So again, here I want to ask you, kindly answer in chat box, what is an interrupt? Yes, what is an interrupt? Obstacle, disturbance. Okay, thank you. Many students have sent their response. So actually we have seen so actually overall the meaning is same. Like your computer is working somehow, and meanwhile input output device want to control. So the input output devices are generating interrupt signal to your processor, right? So that is interrupt. So actually your input output devices is creating disturbance in the program execution. But this kind of disturbance, you can say, this kind of obstacle actually helpful to us. Why? Because of this, we increase the performance of a computer. Here we have seen the various types of interrupts like program, timer, input, output, hardware failure. So in the program also, the many time we require the interrupt. For example, you are dividing any value by 0. So actually the interrupt is required. The error is required. So the interrupt, the timer, if the timer is timeout, again, it is again one kind of interrupt. Input signal generator interrupt for the error condition. If the hardware failure is there, the interrupt is required. So here actually we have seen how the interrupt is beneficial. For to understand this concept, we have taken one example, that is, suppose if you want to print and without interrupt, actually what happen if you are the interrupt is not there, so your computer will send your all the pages to the printer and wait until and unless all the printout get finished, right? So after finishing, the printer will inform to your computer my work have done. So up to the printer is working, your computer is waiting for the printer finish his job. And after the printer finish his job, he informed to the computer. And after the computer get this kind of information from the printer, then again computer will start the execution. So without interrupt here, you will find uh, there is a wastage of CPU time, instruction cycle. Continuously, your computer is checking to find the task complete or not. And you will find most of all the external devices are very slow compared to the processor. So without interrupt, it is a waste of time. But if interrupt is there, how actually the performance increases? Simply your computer will send all the pages to the printer, and after send all pages to the printer and given command to the printer, your computer will execute the user program. Your computer immediately resume to execute the user program, and your printer is doing his job, and your computer is executing user program. And as soon as the computer finish his job, or if there is an error, the printer generate interrupt signal to the computer. Now here you can see how the performance increases. Now here the computer is not waiting to finish the printer job. The computer is doing his own job, and if there is any problem is occur or the task has been completed, your printer will inform to your computer, my task have completed, right? So here you will find how the performance increases because of the interrupt. Again, note here whatever my discussion is there, I am discussing here, it is related to one-human machine. At the very beginning, the very limited resources are available in the computer, so that time it plays a very big role. But the interrupt is very important. Even nowadays, I require the interrupt. This way also the performance increases. Even the good number huge resource is available nowadays. The processor is very efficient. All the resources are efficient, but still it plays a good role. So we have seen the fetch cycle, executor cycle. With this, there is an interrupt cycle. So here I have discussed actually when your computer will check for the interrupt signal. So if after the execution of the first instruction, then your computer will check for the interrupt enable or not. If the interrupt is disabled, it will execute the another instruction, the fetch a next instruction and execute the instruction. After executing the next instruction, then your computer will check the interrupt is enabled or not. So here, what you observe here, so after whatever the instruction is executing, after finishing the execution of that instruction, then your computer is checking for the interrupt. Your computer does not check interrupt. Meanwhile, your computer is executing any instruction. After the execution is finished, the instruction whatever the instruction computer have page, that page instruction execution have done. After that, only your computer is checking for the interrupt. So this is the main thing that you have to understand from this instruction cycle with interrupt. So already we have discussed without interrupt and with interrupt how the performance increases. And these are the different types of interrupts are available: program, timer, input, output, and hardware failure, right? So with interrupt, your interrupt can be a sequential. For example, after one interrupt, there is another interrupt. Yes, it may happen. So X interrupt is there, Y interrupt is there. So accordingly, we have to handle. Sometimes it is a nested. Nested means, yes, there is an interrupt is there. So interrupt instruction you have to execute And while you are executing this instruction, you will come to know there is again one kind of interrupt. So again, for example, again you want to take input to get this, to execute this instruction. So again, you are taking any kind of input here. So it is like, it becomes like a nested interrupt. In interrupt, there is one more interrupt. And sometimes it could be a multiple interrupt. So it is a primary interrupt, and in between there is a two different types of interrupt. So that time you can say it is a multiple interrupt. The next one is that is interconnection structure. In this interconnection structure, we have discussed the different units are there and how these different units are connected with each other. Here we have seen like a memory unit is there, input output module is there, and CPU is there. So how the memory unit getting the data as well as address, at respect to address, but that the data will be stored, and or either you want to read the data or write the data. For example, if you want to read the data, the address is required and the data is required, and as according to the respective address, the data will read and respective data will be transmitted. And for example, suppose you want to write the data. So the write control signal generated, and for the respective location, the data will be recorded, the data will be written. So accordingly here you will find these other different connections are available for the memory. Similarly, for the input output, you will find the read write is there. Either you are taking the input or writing on an output device. That address is required. Again, for the input output, the internal data and the external data is there. External data means, for example, you are supplying the data from your keyboard, and internal data means whatever the data is stored into the memory. So at the output, in the output, from the input output device, what will be the output? Internal data and the external data. Because for the output, for example, monitor is taking the data from the hard disk, so that is called internal data. And suppose if you are typing through the keyboard and the monitor is displaying the same data, so you can call it as external data. And one more, that is the interrupt signal. Now only we have discussed how the interrupt signal plays a role to improve the performance, like in the printer. CPU is there. In the CPU, there is an instruction signal, data, and interrupt pin, address control signal, and data is there. So all these things we have discussed in interconnection. Then the bus interconnection. So here we have seen in the bus, there is a three different types of bus are interconnected with the different types of unit, like data line is there, address line is there, control line is there. So here actually, if you whatever you want to read the data or write the data, what we require, that is address is required, and from the respective address location, we can read the data or either we can write the data on respective location. So address line is there, and to read the data and write data, data line is there. And to control this operation, obviously the control line is required. So these three lines, bus is required to carry a respective data, respective control signal, to carry respective address, so that these bus are available. And how actually, here you can observe how it is interconnected with each other. So what is actually bus? Bus means a communication pathway connecting two or more devices. So already we have seen actually in a bus, and the data bus carries your data, and your bus performance depends upon how many bits your bus carrying at the same time, like 8 bit, 16 bit, 32 bit, 64 bit. So in a bus, actually, how many passengers are traveling at the same time? 8 passengers, 16 passengers, 32 or 64. If your bus is carrying more passenger, like 64 passenger, that time you will call as a bus is more efficient, because the another bus who is carrying only 8 passengers. So obviously the bus who carrying a more number of bits, that is we will call it as best performance. So the address bus carries the address, control signal, various types of control signal is there, like a memory either read or write, input output read or write, acknowledgement, bus request, and grant the permission, interrupt request, control signal. Okay, so up to this we have discussed in unit number 1. I hope all you could understand each and every topic, which is very simple. And the last topic is remaining, which is again very small. Then here our unit number 1 will finish. And today or tomorrow I will submit assignment and test. You have to complete all the assignment and test within given deadline. Okay. So traditional bus architecture and modern bus architecture. So here you will find actually what is the difference in between both the architecture. Here you will observe here the local bus is provided to connect the processor and the cache. And with the system bus, your main memory is connected. Mainly here you will find the main memory is morely utilized because all these input output devices are connected with the system bus. For to connect with all the input output devices like network, modem, SCSI, expansion bus interface, to connect your printer and the scanner, one expansion bus is provided. This expansion bus is connected with the system bus. So whatever the data is going into the cache or whatever data is coming from these input output devices, which are connected with the system bus. But actually, what is the problem with this traditional bus architecture? Here you will observe your system bus, you will find the more traffic is on system bus because your cache is accessing the data through the main memory, and again the expansion bus is uh, either storing or data or retrieving data for these input output devices from the main memory. But traditionally, actually, it is okay. This architecture is best, uh, properly working. But actually, nowadays, you will find the input output devices performance increases, how the data rate is increases. So reasonably efficient. This approach is efficient, but begins to break down as higher and higher performance is seen in the input output devices. But in the input output devices, the the performance increases, and that time this traditional bus architecture is feeling inefficient because here you will find a separate bus is not provided, and again it is a system bus, and the expansion bus is again the data rate is low. So in the high performance architecture, high speed bus is used to connect with the efficient input output devices. So in response to this growing demand, a common approach taken by the industry is to build a high speed bus, and that is closely integrated with the rest of the system. So your high speed bus is connecting with the high performance input output devices, and again through the high speed bus it is with the expansion bus with expansion bus interface. The other input output devices are connected who having a less data rate. So with the expansion bus, the serial bus modem is there, fax is there. So there are separate expansion buses provided for the auto negotiation actually there, because there are the many input output devices which works very slow. So for that purpose, an expansion bus is provided here. Here you will observe the main memory, it is connected on the system bus, and there is a cache breeze is there. So which is connecting high speed bus as well as system bus. And the separate local bus is provided for to connect the processor. So actually here our unit number 1 is finished. So dear students, if you have any doubt in unit number 1, kindly ask me. If you have any doubt